Right, now we've done the sections on the cubics. In this section, we're going to look at the interesting side of calculus as opposed to all the other, which was the nitty-gritty, using it to do stuff. Now we're going to use it to do answers. This is the section on optimization or optimization of functions. It's actually subtitled Maxima and Minima. These, unfortunately, and don't freak, these are word problems. Okay, but they are linked to a drawing. And in this section, we need to know a few basic things: area, perimeters, volumes, etc., etc., etc. If you don't know those, I suggest you maybe get a handle on some of them. In some educators' books, the formulas for them are given, but generally speaking, they're not going to be given. Why am I saying this? Because most often, in the ones I'm going to do now, we're going to be looking at perimeters, areas, volumes, areas, etc., etc., in the types of problems. Just to recap a situation over here. I'm going to take this up a moment. And we are. Remember, f prime of x equals 0. We are stationary point. F double prime of x less than 0, it's a minimum. Usually referred to as a local minimum. Because there could be others. I mean, you get graphs that are going to could have two minima. Like that. You have a minimum here and a minimum there. Similarly, you could have the M graph. There's two maxima. That's why we refer to them as local. Okay? Because it means in that area. Remember, we also had the concavity tests, the second derivative test, the first derivative pluses, increasing, decreases, and the point of inflection. Then, if f double prime of x is greater than 0, it was a, Kevin's written it the wrong way around. What a nana, hey? Sorry guys, I wrote it the wrong way around. I'm thinking way ahead of where I should be. If double prime is less than 0, that is a local maximum. A local maximum. If it's greater than 0, we call it a local minimum. Right? Now, this is what we need to remember these now. Because if I've got a function is something related to something else. So, perimeter is a function. P is equal to 2 times the breadth plus 2 times the length. Area is a function because area is length times breadth. Volume is a function because it's length times breadth times height, or cross-sectional area times height. So anything can be expressed as a function. We now need to break it down, and we're going to use drawings to do it. We're going to break it down into the various functions. Once you get the handle of this, I'm going to give you a recipe which will come out in the wash. So let us look at an example of what I'm talking about. It's the easiest way. Okay, now they're going to give you a whole load of blurb. Blah, 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 blah. What you look for is you look for maximize and what is the other thing that it's linked to. We wish to maximize the area of our compound, field, whatever. Okay. However, we only have 500 meters of wire to do so. Okay? We want to maximize the area of our compound. However, we only have 500 meters of wire to do so. Find the dimensions of the compound. So what are we saying? We're saying that they've given us something like this, x and y, and the area is inside that, correct? We're looking to find we want to make it the maximum. You could have it long and thin, and short and long that way. So x and y are what are going to vary. So first of all, let's just look for keywords. Keywords: maximize area. Maximize what? Step one. Identify what you are asked to maximize or minimize. Step 1. Identify what you are asked to maximize or minimize. Important. Identify it and note it in the question. Okay? Then we say that is step 1. This question is maximum area. Then set up a formula. Step 2. Set up a formula for this. In this case, it's area. Right? We are asked to maximize the area. Therefore, set up a formula. I then turn around and I say, okay, then area is equal to x times y. Step 3 is locate the other piece of info. Locate the other piece of information. What piece of information am I talking about? I'll do that in blue. However, we only have 500 meters of wire. Where's the wire going? The wire is going around the outside of the compound to make up the area. That is called the perimeter. Is it not? So hold on. Locate the other piece of information. I'll just put it in blue. Perimeter is equal to 2x plus 2y. And that must be equal to 500 meters. I assume everybody is with me. So we say the perimeter, we only have this. We only have this. This is, if you like, for those of you who are going to do modeling, this is a constraint. Is it? It's constrained. That's all you've got. You can't use more than you've got. Try telling that to people who try and manage finance. I suppose you can just go into debt. But let's keep this with this. So then I now have a choice. Can you see I have got, let me just take this down, all right? We have got here, I'm going to put it in red. We have got equation 1 comes from there. And the blue is equation 2. Now, I can't do anything with x times y. And in this one, it's got x plus y. So the trick, the key step here is to basically make x or y the subject. I am still in step 3, huh? Therefore, I'm going to say over here, what did I do? I made y the subject. So 2y is going to be equal to 500 minus 2x. Therefore, y is going to be 250 minus x. Now you substitute into 1. You always use, oops, always use equation 2 to subs into 1. 1 is your max or min function. You're going to maximize profit, minimize waste, etc., etc., etc. So now we have got that. So I can now turn around. Let's drop this down where you can see y is 250 minus x. So I am going to substitute 250, y is equal to 250 minus x into area is equal to x times y. So therefore it's going to be x times 250 minus x, which is 250x minus x squared. Cool. Then step 4. Step 4. Step 4. Differentiate this function to find f prime of x and f double prime of x. So in other words, you find first and second derivative. So how do I do that? I say, right, dA by dx, because x is the variable, is going to be 250 minus 2x. And if you can remember the notation, d2a over dx squared is going to be, this is a constant, it's 0, and it's going to be minus 2. So my second derivative is minus 2. Therefore, immediately, the f double prime of x is less than 0. Therefore, the point is that's a negative, so it must be a max. Right? This is all we're doing. And what do I do? First and second derivative, and put first derivative equal to 0. So second derivative and put f prime of x equal to 0. That is exceptionally frustrating when it doesn't show the eraser on top. Oh, come on. Okay. So I then say that is my recipe. I put the first derivative equal to 0. So therefore 250 minus 2x must be equal to 0. Minus 2x must be minus 250. X must be 125. Therefore, if x equals 125, what's y? The other one. Go to the formula and I can see I went and said, oh, there we go. Back substitute. Back substitute. And I'll show you. If I back substitute, I end up that y is equal to 250 minus 2x, which is going to be equal to 125. Therefore, x is equal to 125, y equals 125. 125 times 4 is 500. So you've satisfied the constraint and you have made it as big as you're going to get it. I think you can see the general recipe. Here's another question. Example. While I wait for this to do its thing. Example. Given f of x equal to minus x squared plus 3x and g of x equal to 2x squared minus 3x, we've got two parabolas like so. Okay, g of x there and f of x is the one above. Now, this is a typical one because they're going to say a vertical line is drawn called AB. So then I say, okay, there's A and there's B. This is point x1 and point x2. That's just where they, in fact, are going to cross each other. Intersection, correct? You can go work that out if you want to. You don't need to. Calculate the maximum length of AB. What on earth are they talking about? All right, calculate the maximum length. In other words, AB can move. Because AB can be there or there. Because X can go from there to there. It is inside there. Obviously, if the line was out here, it doesn't have an answer, does it? The line just gets bigger and bigger and bigger as it goes out. But within this area here, as I move my X, the line is getting longer and longer. There's a point somewhere over here where it's going to be as long as it can be. Now, how do I find the length of a line? Let me just go back to this here. We're actually saying, I want to just use blue, this is the length of the line. The length of the line is actually the y-coordinate minus the y-coordinate of A minus the y-coordinate of B, is it not? It's vertical. So it's the length of that piece of line from A to B. On that score, therefore, can you see that the length is going to be given by the y of A minus the y, but that's f of x minus g of x. In essence, the rule is you always start by saying that the one on top minus the one below. Just put that back onto black so that I get my colors. So length AB, let's call it LAB. Why has Kevin gone and done that? LAB, okay, is equal to, and in this case it's going to be f of x minus g of x. It's going to be the top function minus the bottom function. Obviously, because it's the top y minus the bottom y. You'll just get a negative answer if you do it the other way. It could mess it up with square roots and things like that. But try and put the top one at the top and the bottom one, just so that you keep it nice and tidy and positive, because it makes life easier. So f of x, you then say, is minus x squared plus 3x minus g of x, which is 2x squared minus 3x. Now, this comes out to be minus 3x squared plus 6x. What was that? Okay, this is now my function. I don't have any other info. So what do? I take the derivative and I say dl by dx is going to be equal to minus 6x plus 6. And I take d2l dx squared. I'm just following the recipe, is minus 6. It's negative. Okay, therefore, I am working a maximum. I wanted to do that because I want maximum length. What do? I put the derivative, remember, put f prime of x equal to 0. Minus 6x plus 6 equals 0. Minus 6x equals minus 6. X is equal to 1. Therefore, the length at x equals 1 is a maximum. And you can go and work that length out if you wish. You would just go back up to your formula and you would say if x equals 1, L is going to be minus 3 times 1 squared plus 6 times 1, which is minus 3, is going to be 3 units long. Very straightforward. Now, what I think I'm going to do is I'm going to do the next two on in a separate one, maybe a shorter video, but I'd rather keep them a bit shorter than overload because these are getting quite heavy now. So I'm going to stop this one here. But remember, the recipe says look at it and draw it first of all. Because once you draw it, you can see it. Label it, then look at what have they asked you to maximize? What have they asked you to minimize? If they've asked you to minimize, right, or maximize, find the function for that element. So if they're talking about volume, minimize volume, then you've got to find an expression for the volume, and then that's going to be your function that you're going to be differentiating. Find the second piece of information, use that, write it in terms of the other one, and substitute in so that you've either got an X or a Y or a V or an R or an H or a whatever in there. You'll see in the next ones. Cheers for now. I'm going to go and do a second one.